Now I want to talk about this one. This is number 11B. This is, again, this is one that Hafong asked about in class. And I want to go over it. It's very unfair to you as students because it's not even covered in your book. However, they do give a worked example. So let's look at that first. Actually, let's not look at that first. Let's look at this first. We have a parallelogram, and this is a vectors question. So we're trying to write the vector WZ in terms of A. And I'm sorry, I'm going to fix that. That's bothering me. Okay, that looks a little cleaner. So we're going to look at this top one now, and we're going to write WZ, vector WZ in terms of A. Well, notice how we're going with the arrow. So all we're doing is we're just going from W to Z. So WZ, vector WZ, is equal to A. So the answer would be WZ equals A. Sorry, that handwriting is atrocious, but it's difficult to write on this with my finger, and they didn't provide me with something a little better to write with. Okay, the next question, write ZW in terms of A. Well, now we're going against the arrow. In this instance, we're not going to have a positive A, we're going to have a negative A. So ZW, here, try this. ZW is going to be equal to negative A because we went against the arrow. Now it's going to get a little bit trickier, but it's not too bad compared to what we're about to face. Okay, so now we have to go ZX. We're going from Z to W to X. We can't go across because there's no diagonal, or we can go Z to Y to X. It doesn't matter. The result's going to be the same. Let's just go around this way. Negative A plus B. That's how we get there. The answer is negative A plus B. Okay, so now we're going to do XZ. We can go either way. The solution is going to be the same. We're going to go against the vector to Z. So A minus B. We've got a negative B and a positive A. So A minus B. Now we've got to talk about this, which is called the parallelogram law of vector addition. Now when you take the test, I don't think, if you don't know this, I think maybe you'll drop a couple points. Maybe you won't even be on the test. But those of you who want to do really well, it's definitely worth your while to learn this. So what it means is, if you have two sides of a parallelogram, the vectors are moving away from each other, then this diagonal, by the way, just to remind you, the diagonals bisect each other. And some of those problems, you have to know that property of a parallelogram. But with this law of vector addition, when they move away from a point, this is going to be the sum of the two vectors, the diagonal. Now, the worked example from your book, worked example 15, which is it's given to you with that very little background knowledge, is that AOACB is a parallelogram in which OA is equal to A, OB is equal to B. You can look at the image and see that. M is a midpoint. This you need to read. M is a midpoint of BC. So this is a C here. I cut it off on accident. M is a midpoint there. And BC. N is a midpoint of AC. So keep in mind that M and N are midpoints. And we have to find OM. So we have to go from O to B to M. We can go the other way too. The result's going to be the same, okay? So we're going to go from, because we would go in a negative direction. Actually, let's go in the more difficult way. So if A is going this direction, let me get my pen. Okay. So these go in the same direction, and sides of parallelograms are congruent, as you know. Now let's just forget, you know that the arrow is going this way, and you know that the B is going in this direction, the vector. Okay, so we're trying to get to M. So let's go in the more difficult direction. So we're starting here, we're going around here, we're going here. And what we're going to do is we're starting at O, and we're going to add A. So we have a plus A. So we go to OA, vector sign, plus AC, vector sign, plus 1/2 CM. But I made a mistake here, and what's a mistake? No, I didn't. Wait. Yeah, I did make a mistake. And the mistake is the vector is going in this direction. Now we're going against the current, I guess, so to speak. So instead of adding 1/2 CM, we're going to subtract minus CM. So now we're just going to, this is letter A. You have that confusing numbering system. So let's go ahead and figure this out. So OA is just small a plus B minus 1/2 of A. So our solution is going to be B plus 1/2 A. The second part, we have to go to MN. Let's go the easy route this time. So we're going to go from here, from M to C to N. But this isn't BC, it's half of BC. So it's not A, it's 1/2 of A. We've got 1/2 A. I'm getting better at this. You can see my handwriting is getting better. Because M's a midpoint, it's just half, and N's a midpoint. However, we're going the opposite direction of the vector. So we're going to subtract 1/2 of B. Algebra. And there we go. View this for a moment before we look at the problem. Try to glean the information from here. And let's have a look at this. Okay, we've got the parallelogram and the diagonals intersecting at X, so they're bisecting each other. And so we know if we go here, this is A plus B. So PQ is A, PS is B. Find QX. So we've got to go here, here, and here. Well, actually, I take that back. We have to go here. Let's go here. Let's think about where we have to go. Okay, look, it's got to be moving in different directions for this to be true. So we just have to go, what is it? QX. Okay, so we have to go from here to here. So you can try it on your own or whatever, but I'm going to go ahead and solve it because I'm about to go home. So we're going to go from Q to P. So we're going against the direction of the vector. That's negative A. Oh, no. It's so annoying. Okay. Negative A. And then we know that PR is A plus B, but PX is half of PR.